Hello everyone. I'm Beatriz Amante. I work for Coal Miner 42. I am I'm working mostly as AI expert. I'm trying to be an AI expert at least at that. And today I'm gonna talk a little bit about how to train a model for inference. This talk is mostly about how to train the model, not about like all of the logics and things that you should know if you want to begin training a model. So some things that it's important for you to already understand or at least have some kind of idea behind is that I'm not gonna explain what hyperparameters are or what weights are, or like I'm not gonna um, uh, explain about classification and generation models and the difference between them, or and some code decisions that I did in my project. I'm also not gonna talk much about that. I'm gonna brush over these things a little bit, but as we have like a limited time here, not gonna get too deep about those. So let's begin. And first of all, each model has its own set of data that you have to deal with, and it has its own problem to solve. Let's say, in this project, I am trying to solve a person tracking problem through video feed or through images that can be fed to a program, and then the AI will be able to detect the person in the image, and then it will be able to embed the person's identity from the image to try to match to see if it's a match or not. I am using two convolutional neural networks. That these are AIs that are state of the art for image processing and things like that. And why I am training these models specifically, not every model will work for every problem that you have. Each model has its own speciality. Um, so you have to know which architecture you're using for the problem that you need to solve. And usually for image models, you would need a pre-trained model or a pre-trained set of weights. So the model doesn't have to learn about how to differentiate borders and structures and geometry and things like that. So nowadays, for the models that we have, you use a ImageNet already pre-trained model, and you will only just get like the half-trained weights and fine-tune them, or like add some layers or get some layers differently. So it depends on what you need and why we are also getting a pre-trained model if you can get one from scratch, because it's honestly it's really time consuming and it's really heavy on your computer. So it's good that you are able to already train a model that is not going to take like a whole month to train. Instead you will only get a couple of weeks or so. And so for my case, as I said, I needed a model that could track objects on image, and another one that could get the identity of a person, the mathematical identity of a person, and compare to another set of identities to see if the persons are matching. So the at first when you're choosing the model to train, you have to think about the data set that you're gonna feed the model with. Usually for new things, like for new usage, you will need at least more than 1,000 or so examples of images, of annotated images that are images with annotations, for example. So for my object detection, I am using YOLO. That is, you only look once. That's the name of the model. I mean, and with the Coco data set, that is common objects from Microsoft, and Coco already has like the bounding box coordinated annotations and the class annotations, and it has over 300,000 images. And for the identity processing, I am using Duke TMC ReID that it has over 36,000 images, annotated ones as well. Not all of them are annotated, but like most of them are. And it's important to remember that, like, when you getting this data sets, you will also have to use some pre-processing, not rules, but methods to crop the image, to resize the image, to change the lighting, so the model can deal with different sets of images and learn to generalize better from those images. And also, like, as each model has its own set of usages and architecture behind it, they will also have their own benchmarks, like their own metrics that you need to use for them. And you will have to learn how to read those metrics too. So in my case, for the dual object detection, you cannot use the same model that detects an object and classifies it as a person or a car or something else to also identify the person. Usually, you would need an integrated pipeline between two different models for that. Like strong sort, for example, it does that. But first, I needed to detect the objects and to know that that object is a person. So that's what YOLO does. I trained YOLO for that, and then you're gonna have to get the image and crop it using some Python image shaping codes. And with that, after the image is cropped, the model will transform it into an embed. It will transform first actually in the tensor that OSNet needs to have to understand that it's an image that it can identify. And after you have that, you will be able to get the feed it to the person re-identification model, and it will return the person's array, a numerical array that is a vectorization representation of the model. So it can kind of be like, in the model's perspective, you could see like this, for example. And for YOLO itself, I use the framework that is called Ultralytics. That is like a wrapper of a lot of YOLO functions, and it also has the metrics already scripted inside the framework, which really saves a lot of time. So, for example, um, the model itself, when you are building the base of the model, this is how you usually would need to just partially. I'm gonna just show some partial parts of the code behind it, but this is how you usually would have to build the model. You have to create the convolution array layers, the forward pass, and all of the instances to set the classifier. And with Ultralytics, that you only will need to create an object, that YOLO object. They will and feed it the the model weights that you have already set, or you can either feed a partial one or come from a one from scratch, for example. And then you just kind of call this model, this YOLO object, and call the method train. Um, Feeding the correct hyperparameters. So always remember that if you are trying to train a model from scratch, you will need to learn what each hyperparameter is, because it's really important to watch out for them when you're seeing the metrics, and if the model is behaving how it should, how you want it to behave. And secondly, for OSNAP, that is the identifier model, I am using the framework that is Torch ID, Torch ReID actually. And because it also simplifies a model for me to use, and it makes it way less time consuming than to have to to build everything from zero. That is the like the convolutional layers are also like this because like it's a convolutional neural network, so they, they usually behave kind of similarly, even if their architecture is kind of different in the end of things. So for tertiary ID framework, you would just have to build a model with the correct hyperparameters. You have to build the dataset manager, the optimizer function, the learning rate scheduler, and then you're gonna build a model and just train the model. And after that, you're gonna after the model is completely trained, Ultralytics already gives you the some of the metrics that you need to see if the model was correctly trained or not. So you have to watch out because, like for example, for YOLO, the recall function will never reach much higher. It will never be too close for the precision function. There is a part on you only look once paper that tells us that because the YOLO is trying to identify to classify the boxes better, like the if they which object those boxes are around it, it will have a higher precision than a recall function. So also keep an eye for that, and also the boxes don't need to be perfect. That's why the this map 5995 it's lower than the only the 50 because this one is based on exact matches of the all of those boxes, and YOLO's whole idea is more about being able to identify the correct objects than to perfectly get the bounding boxes around the object. So that's that. And as you can see on the metrics here, the models are converging very close to each other on the training set and on the validation set. So it's going at least after the fifth epoch, the fifth training iteration, they are coming really close together, and that's what we need. So it's training all right. Um, and it's also not causing overfitting. What is overfitting? Overfitting is basically when the model kind of decorates the data set that it has. So it's not learning new features, not learning to generalize new features. It's only decorating from the data set. So when you get the model for inference, it will load it up, for example, and it will not be able to deal with real life new data. So this is what overfitting is. And when you see one of these metrics, for example, when the overfitting happens is when the models are almost converging, both the training and the validation losses. But at some point, they will have a different measure, and they will start to diverge. That's what basically is it. And I am using for now the Google Colab because training a model is it's very heavy on your GPU and your CPU. So just an example here, I was doing some tuning in my YOLO model, and this is like the how much energy the GPU is gonna use on the multiprocessor, the generate power in watts, and the power usage in percentage. So it's really heavy. So it's good if you have either a very good computer, a very good graphics card, or you can like hire a Google Colab notebook, for example, to research on that. And as this one is mostly about training, I have like the code here. For the training, you have to get the data set and like to build the data set correctly here. For YOLO, it needs dataset that .eml, where you will tell it where the images are and where the validation images are, and which classes are you training it on. Here, the number of classes that you're training, And you have to turn the labels from a .json notation into a .txt for each image. It's gonna take a little while to load here. Um, Checking if the which kind of if the CUDA is available or not. And here, as you can see, it has a .txt for each image. If I open the image here, you'll see that like it has the same it has matching labels for each image as it has on the labels here. So that's what is needed for. And here you can just build a model, loading the path that I gave it here, because I already have for YOLO. I already have a trained one, and I only made an one epoch here, so we're not gonna take the whole day trying to train it, and just building the training set and the pipeline for the training set. And just I already loaded the training before beginning this video, so it's already finished here. But as you can see, it will build the convolutional layers. It will go through each layer. Will freeze the layers that I told it to freeze, and then it's gonna load the image to the VR run, and then it's gonna just keep training until it finishes, and it will save a new model here where I told it to save. Let me show it. It's in runs. This is my old one. Oh god, my computer is gonna crash. Yeah. Baseline. Oh no, it wasn't here. It was in my drive. Runs. No, you run the tactile. Yeah, I put another one inside here. Okay, waits here, and it's gonna have a dot PyTorch file with the weights inside, and then the as I said the metrics are already here. It will have some um, batch training images too already with the bounding boxes. Once it loads, and let me see, it will have some other box curves too. It's gonna load eventually, so I will show you when once it loads. And when you load the best weights, that's what it means. And it's gonna show like this, the how it was built and the parameters behind it. And for OSNet, I already pre-trained it. I have another model that was already trained with 250 epochs. That is 250 training in training labs. Let's say I forgot the correct name for that. It's basically almost the same thing. You just have to set the hyperparameters. I always see which CUDA I am using, and just build the model, put the model on the on CUDA, because it will load the model on where it needs to be loaded. Build the data set manager, and just build the training set, the optimizers and everything. And once it's ready, you can just run. And here also it will load the the image inside of the data set. And we're gonna show the epochs running. I only run one epoch here. And this is a model from scratch, not from scratch, but it's not a pre-trained model, as I already had another one here. So this is are some of the metrics that use for personal identification. So that's how you usually train a model. Again, like for usually all the models have the same base. You have to prepare a data set for that. You have to prepare all of the convolution layers behind it. Or if it's a generational model, you will have to prepare the self-attention mechanisms and the transformer architecture behind it, feed it, and just train through a lot of data. And you usually give you back some kind of dot PyTorch tensors, or it can be also other kind of tensors depending on what you're trying to build. So, and after you have that, you will be able to load this new tensors into a model file and just use it. I will show how to use it in another brown bag in the future, but that's it. I hope I could help you in something, and thank you for watching.